where I'm going to be kind of talking about more practical things, such as how to create your own beautiful screens for your application, and more importantly, how to properly do lists and work with more complicated Android components. So let's get right into it. I guess before we can begin, let me again just reintroduce myself for anyone who's joining in for the first time. My name is Bobby Wong. I am a 4A computer science student at the University of Waterloo. And for my Android experience, I've done 3 Android internships in the past and have 1 planned upcoming Android internship. And as for my outside of work Android experience, I've also published 2 Android apps to the Play Store under my name. So lots of Android experience. Really glad you could all join me for some late night Android programming. All right, let's get right into it then. I'll be starting up talking about what we're going to be doing for today. So the first thing I'll be talking about is finally going to talk about Kotlin and some of the Kotlin features that I really appreciate and why I choose it over Android. So just a little like toe dip into the world of Kotlin and some things that I hope you can use if you do choose to use Kotlin for Android or for anything really. After that, I'll be moving on to what's called constraint layouts, which I believe is like the best way of creating complicated looking screens for Android applications. We'll be ending the constraint layout section with a quick not tutorial, like a quick assignment where I'll be having you guys create something on your own, which is what the 5-minute break is for. So give it your best in that 5-minute break. If you can't get it, that's okay too, because I'll be showing the solution for the assignment after the break as well. After the break, we'll be talking about recycler views, which is pretty much, in my opinion, like which in Android is the only correct way of displaying lists. So if you do plan to have lists or anything to do with like that, then you do need a constraint layout and the recycler view, and to understand how it works pretty well in order to make the most of it. And then at the end, we'll be having a short 5-minute Q&A for any Android or even software or career questions you might have. At the end, I'll be having my 2 workshop helpers join in as well, so more than just my perspective for that section. On that note, my 2 workshop helpers for this session is going to be Chiyuan Bao and Arjun. So if you see them answering your questions, that's why they're answering the questions. All right, let's get right into it and talk about Kotlin and why I use it and why I think you should use it over Java too, actually. And I talked about this a bit in the first session. Basically, Kotlin Android's not really dependent on which language you choose. It's more dependent on which SDK how well you know the Android SDK. So it's not really much of an investment to learn Kotlin over Java for Android, but you do like reap a lot of rewards out of it, which I'm about to talk about. Okay, so here I have a list of basically what I think are advantages Kotlin has over Java. And I actually have a little short programming example here. I think I uploaded this, but you don't need to follow along. I'll just kind of be explaining kind of what each of these features mean and how I can apply it to make this code much cleaner. Oh shoots. Let me quickly talk about this then. Hopefully everyone can read the code, but basically what I have here is a super basic Android application. What it does is it'll basically, first of all, the application will create a list of ints and nulls. So it's a list of 1, 2, 3, null 4. What it's going to do to that list is it's going to process it by adding 1 to all the integers, but keeping the nulls the same. And it's going to take that data, convert it to a string, and show it in the text view. And as you can see here, that's exactly what it does. So we see that the 1, 2, 3, null 4 becomes 2, 3, 4, null 5. So pretty simple. But I purposely written this program kind of badly, and badly in the sense that I tried to emulate what I would do if I was writing it in Java. So as I'm going through each of these points, I'm not sure if you can read it, but as I go through each of these points of Kotlin advantages, I'll be kind of showing what that means and how I can apply it to this specific program. Let's get right into that. Okay, so the first point I have here, you might not be able to read it, but it says Kotlin is designed to be compatible with Java. And actually, it means more than that. Kotlin is actually meant to completely replace Java. So anything you might want to use Java for, you can technically use Kotlin for in its place. And that includes Android as well. I won't be making any changes for this file because of that point, but just keep that in mind. They're meant Kotlin is meant to play nice with Java. So you could totally have a program that's half in Java, half in Kotlin. But if you're starting from scratch, then obviously all Kotlin is the best way to go. All right, let's talk about the next point, which is val, var, and nullable type. So I kind of breezed over this, but in Kotlin, to start a variable, you start with either val or var. The only difference is val means that the data cannot be changed. So if I try to change this, you'll see that it's going to complain because it's a val. But if I change it to a variable, then that means it's no longer, that means you can change it now. In this case, let's keep it as a val since we want to kind of keep the list final. We don't want to change the actual list. So this is fine as like a val value. We give it a name, and then we use colon to give it the type. So this value has a type of list of int. It's a list of int question marks. And in this case, actually, the question mark is what we call a nullable type. And all it really means is that this type can either be whatever came before it. It can be either be an int, so 1, 2, 3, or it can be specifically a null, so null here. And if you can see, if we remove the question marks, then this null is no longer valid. And we can actually add this question mark nullable anywhere after any like variable type. So we can actually even add it here as well, which will make reassigning this whole thing to be null possible, which it actually wasn't before. So let's move on then. Okay, Kotlin is very good at inferring types. Kotlin is a statically typed language, so even though you see val and var, that it doesn't mean that variables can have whatever type they want. Since we declared it as a list of int question marks type, this data variable has to be a list of nullable ints. It's not like Python where we can reassign it to whatever we want. But one nice feature of Kotlin that I really love is Kotlin is very, very smart. So even you can see here, this list of function, it knows it's getting ints and nulls. There's no point in us explicitly telling this list of that it should expect int nulls. We don't need the explicit type declaration. It's smart enough to know that it's getting int and nulls and that it should be a list of int nullables. And we can actually take that a step further. This data declaration is just as smart as well. It sees that it's being assigned a list of int nullables. So we don't even need this declaration. We can take that whole thing out, and Kotlin is smart enough to infer that data should be the type int list of int nullables. We can apply the same thinking here, but I'm actually not going to because we're going to replace it very soon. So let's talk about the next two in conjunction then. Kotlin uses lambdas a lot, and Kotlin is a functional programming language. Two very big words there, functional and lambda. I'll be explaining functional programming language first, and you can see this process data function. What it's doing is it's creating a new list. It's applying a transformation to each item in the list and adding it to that new list, and then it's finally returning that new list. And from experience, I actually know there's a function that does all of this for us, and that function is called map. And because Kotlin is a functional programming language, it means that functions are treated just as variables. And just like variables, instead of declaring out this entire function from scratch, we can just reassign it. A bit of an oversimplification, but that's basically what's going on here. I can reassign it to that map function, sorry, data.map function. That's going to take this list, it's going to create a new list, and the content of that new list is going to be the old list with a transformation applied onto it. And in this case, map actually accepts a lambda. And this lambda is basically a block of code that it's going to run on each individual list item. So I'm actually named it item. So let's name it item. So if we just take the exact same code we had from before, if an item is null, then just keep it the same. If it's an integer, then add 1. We can take that old code and just replace this entire process data function by reassigning it to the map function. that already existed. No worries if you don't know what map is. The idea here is that um, because Kotlin is functional, we can do this kind of things with functions. And if I run it, we can see that it's going to do the exact, it's going to show the exact same thing as before. One quick note is that I don't type return here. It's smart enough to know that because we're just saying just like a value, it's smart enough to know that this is the value we want to return for the map. But anyways, let's move on. Okay, extension functions. So as you probably know, every class, so like such as this list of int nullables class, every class has a bunch of functions available to it, like get or last index, for example. Let's say we want to add a new function to the class. That's actually possible in Kotlin. All we have to do is take the class or kind of the type we want to add it to. So in this case, we want to add it to all list of int nullables. And we just kind of add it as a precursor to the function name. And then we add dots. And just like that, just by doing that, now every instance that's a list of int nullables will have access to this process data function. So now we can do data dots process data. Wow, terrible name. But anyways, and this really is as if we were calling like this, so if we were calling a function from within a class, because now instead of passing data in, all we have to do is this dot map. And this dot is kind of redundant, so I'm just going to erase that. But anyways, just by doing that, we've added a new function into the list of int nullables class. It's that easy in Kotlin. All right. Data classes I won't talk about here. I'll be talking about that in a later section, in the Recyclerview section, but I'll be covering that. Okay, the last two are the kind of the most confusing to get, so I really hope you all kind of try this out afterwards. But nullability support and especially scoping function, that's going to be the most confusing one in my opinion. You might be wondering, why do we bother with all this like question mark and all the nullability? Why do you have to explicitly state it? And that's because Kotlin is very good at supporting nulls. And we can actually replace, there's actually a special operator in Kotlin where instead of calling things with a dot, we do question mark dot. And what that basically does is the question mark will check if the thing before it is a null. If it is a null, it's just going to break out of the whole thing. It's going to return null for whatever the whole line is. But if it isn't null, the question mark lets it through and execute whatever follows it. So in this case, a dot. What should we execute? We should execute what's called a scoping function. In this case, let's. And what let will do is, that kind of makes sense intuitively through English actually. Let's take item, let's take it and add one. What let basically does is it's going to take whatever it's calling it and pass it into a lambda as its. So let's take item and add one to its. And if item is a null, this question mark will catch it and not execute this. So if I run it, just like before, it still returns 2, 3, 4, null 5. So like as you can see here, using Kotlin, we've reduced like the amount of code by a lot. But more importantly, I think if you get used to how Kotlin works, it becomes a lot more readable and a lot more like a lot nicer to work with. Where the kind of things we're programming is kind of what you're actually thinking about to solve a problem. You're not really thinking about boilerplate and like how to work with Java and like what are the various Java functions and classes that you need to call and whatnot. In my opinion, working with Kotlin is a lot more intuitive and compact. And Kotlin does also have a lot of other really nice advantages over top of it as well as over top of Java as well. But I won't be talking about those in this section. I will be going over somewhat like one of them in the advanced section. But for now, this is just basically the most basic advantages of Kotlin. All right. With that, we're ready to move on with the workshop. So if you're following along with the code, and I want you to open the Recyclerview demo repository, or if you're not, just create a new project from scratch. But we're going to get started on the constraint layout section, which is going to be a section where I talk about if you want to make like beautiful looking UIs like this with many complicated components, what's the best way of accomplishing that? And in my opinion, well, actually, it's pretty well known, but like the best way of doing that is through what's called constraint layouts. All right, but before I continue, let me talk about why we need complicated and like fancy layout formats in the first place. Like, why can't we just kind of drag and drop views in and like kind of paint it as if how we want it to look? And the answer to that are these two images. So I talked about before how I have two apps published under my name in the Play Store, and this is actually one of them. So this is a screenshot from the application I made. It's not super advanced, but the thing I want you to notice is that even though it's the exact same screen and the same content, you're going to notice they look slightly off. They're not exactly the same. And that's because these two screenshots come from two different phones. The one on the left came from a Pixel 2 emulator, while the one on the right came from a Samsung S4 Mini emulator. These two phones have very different screen sizes, resolution sizes, screen aspect ratios. They have different Android versions on them. They have so many different, they have so many differences that it's hard to make the views look the same if you don't do it in a smart way. We need to make sure our views look great no matter what phone it's on. And that's why we need a complicated system like constraint layouts to make sure that always happens. And what constraint layouts is really good at is constraint layouts are really good at positioning views relative to each other. So things like, I want this text view to show up after this image view, for example. So like placing things relative to each other. They're so good at it that they're actually better at doing that than a relative layout, which you might see around if you look through like Stack Overflow threads. And please do not use relative layouts. They have pretty much been completely replaced with constraint layouts. So if you do want to create like really fancy looking screens, then constraint layouts is definitely the way to go. But after all the praise, let me talk about what are some of the things that constraint layouts are really good at. So first thing is, constraint layouts are really good at positioning items relative to the parents. And as in this case, the parent is probably going to be like the actual screen. So if you want to do things like, I want this view like in the very center of the screen, then constraint layouts are really good at that. If you want the top left corner or the top right corner, then that's not hard to do with constraint layouts. In a similar vein, constraint layouts are also really good at aligning views relative to each other, like I said before. So just like I said before, things like, I want this text view to follow the other one, and so on and so forth. One other thing that constraint layouts are really good at is that they're really good at adding margins and white space. So things like, I want there to be a small gap between these two views, or things like I want there to be a large gap between these two views. You can manage that really easily with constraint layouts as well. Finally, they're really good at animating view transitions and moving views around using animations. I will be showing that today, but the general idea is that you can create a constraint layouts of like the before animation and one of the after animation. And there's a really handy Android SDK function that you can just call with the two constraint layouts, and it'll automatically generate the transition for you. All right, so let's get started with the first thing constraint layouts are really good at. So I asked everyone to open up into Studio with the exact project. I guess the first thing I want to do is I want everyone to open up the projects tab and navigate to the resources layout folder. From there, I want everyone to right-click and create a new layout resource file. And by default, the root element should already be a constraint layouts. So all that left is to name it. And I want everyone to name it something along the lines of list_item. I'll be talking about why this is in a bit, but this is basically the file that I'm going to be assigning the assignment on. But anyways, so like I said before, this part you don't have to follow along on, but if you want to, you definitely should, because playing around with constraint layouts is the best way of kind of understanding how they work. And if I drag a text view into this layout here, you can see these 4 white circles. And these 4 white circles are basically indicating places where we can add a constraint. So if I click on one and drag it, we can see that there's no arrow, and we can drag this to basically anywhere we want. Well, I guess because it's a vertical circle, we can add it to the top or bottom, so on the vertical axis. But we can add it to the top, and just by doing that, we've aligned this text view to be stuck to the top of the parent. We could do the same thing with the left, and this will basically stick the view to the left of the parent. So this is basically how constraint layouts work. All we're doing is adding these constraints that will basically pull and push views around. And just like I said, it's going to pull around. So if I add one more constraint from the bottom of the text view to the bottom of the parent on the screen, we can see that they're both pulling equally. So it goes to the middle. And same idea here. And constraints are actually really flexible. As long as you're adding constraints on the same axes, you can add constraints basically however you want. So if I wanted to do something dumb, like add a constraint from the end of this text view to the start of this screen so that it's off screen, I totally can. There's nothing stopping me. Okay. One quick note is that even though we can drag this view around, this doesn't actually move the view around. This is just for our own preview purposes. How we actually position the views is all through these constraints. All right. Let me quickly talk about layout width. And actually, let me get another text view in here just temporarily. Okay, so if you've worked with Android before, you're probably aware of the various layout size options. So wrap content will make the view exactly big enough so that it's wrapping all the content of the view. So in this case, it's just big enough for the text. You're probably also familiar with let's do it in this code section because I don't like doing it in the other one. So text view 2. Let's make the width. You're probably familiar with match parent as well, where it will make the view as big as whatever container it's in. So in this case, the entire screen. But in constraint layouts, there is a third special one called, well, it's called 0dp, which is a terrible name. But if I make a view 0 display pixels wide, instead of going infinitely thin and invisible, what it actually does is it's going to match constraints, which basically means it will make it as big as it needs to be without breaking any of the constraints in place. So you might have noticed I added a constraint from the start of this text view to the end of this other one. That's why if I make it 0dp, it'll stop right here, because if it goes any further, it's going to violate this constraint I placed. All right, let's move on then. You already have a sneak peek of this, but constraints are really good at positioning things relative to each other. So if I have a text view like this, like in the top left corner, then let's say I have a second text view, and I want this to be below the other one, but slightly indented. Like I said, constraints are really good at that as well, because I can take a view and I can add a constraint from any of its four directions onto another view. So let's say I want them to start in the same place. All I have to do is drag. Let's say I want this to come after that text view. All I have to do is drag this circle onto the end of that other one. And now they're aligned horizontally or vertically. They're aligned in this direction, basically. I could do the same thing, taking one from the bottom of this text view to the bottom of that text view. And now they're aligned vertically too. And you can attach constraints basically on any way you want, as long as it accomplishes the goal you want. Yeah, sky's really the limit here. Okay. Let me quickly put this in the center. Okay, the last thing I want to talk about are constraint layouts chaining. So you might notice from, yeah, constraint layout chaining. So you might notice from this picture here, these three views, A, B, C, are positioned equidistantly from each other, while also being spaced out in the view. And it might be kind of confusing how to do that if you're new to constraint layouts, but thankfully there's a really easy way to accomplish just that. So let me add 3 layouts in. All you have to do is select all the layouts that you want to position like this, right click, and add a, oh, I didn't select them. Oops. Right click and add a, oh, why is it not letting me right click? Okay, there we go. So select all of them, right click, and add a new horizontal chain. And this will add all the chains in place, all the constraints in place, such that they're exactly like they're shown here, positioned equidistantly. But like I said before, anything you do in the design tab, you could do in the code tab as well, because all layouts really are these text files. And if you look at it, you can see that all constraints really are these lines here. So this text view has a constraint from its bottom to the bottom of text view 3, which is exactly what's happening here. There's a constraint from the bottom of this text view to the bottom of text view 3. So yeah, if you want to use the code tab, you can feel free to as well. And all chaining really is, like, and you might see it from this image, but all chaining really is a complete kind of graph of chains going in both directions. So nothing magical about them, but handy to know the shortcut. All right. Before I move on, let me talk about one last thing to do with constraint layouts that are specific to text views. So let's say you have 2 text views like this, and you want to constrain them vertically, but you want to constrain them vertically along their text. Then all you have to do is right-click on a text view, show baseline, and then drag the baseline over. And what this will do is this will align the text, this will align the views based on their text. So even if the text grow and shrink or change sizes, they'll still kind of match along the bottom. Okay, let's move on then. Okay, the last thing is pretty simple. Constraint layouts are really good at adding margins, and this one's pretty much, in my opinion, the simplest one. Erase some stuff here. This one's, in my opinion, the simplest one because you can do this is pretty simple with any view, but there's some nice advantages of constraint layouts that make it even easier. And that's this little constraint widget here. You're going to see that whenever you add a constraint, it's going to show up here, and you can edit the margin a view has using this little drop down. So let's say I want a small gap. All I have to do is I click on the drop down and select how big I want the margins to be. So, 8's pretty small. Let's make it 16. Yeah, nothing difficult, but super handy because of constraint layouts. All right, let's move on to the assignment then. This is going to be the hard part where hopefully you can apply what you learned about constraint layouts and create something. No worries if you can't get it and make this layout, because I'll be showing you guys how to make it after the break. But basically, what this layout is going to be used for is after the break, we'll be creating a Recyclerview layout, which is basically a list view. And just like any list, we need a layout to determine how each item in the list should look like. So I know up to this point, I've been talking about layouts as if they have to be for the whole screen, but that's not the case. You can make layouts for whatever you want. And in this case, actually, if you want to make it for just one individual list item, you might see it from the blue rectangle, but layouts don't have to be the entire size of the screen. You can make the layout height, for example, to be wrap content, and that will make the layout like as small as it needs to be, like how a list item should be. But yeah, anyways, everyone, give making this view a try using constraint layouts. Good luck. If you have any trouble, you can ask us in the chat. I'll be still on the call answering questions verbally. But yeah, good luck. You'll be given 5 minutes to create this layout. I guess I'll leave this view up so you guys can look at what you guys are supposed to build towards. Hopefully it's more visible now that I made it full screen. All right. Oh, I got a split view. That's a good question. So the question is, how can you show how you got the split view again? So yeah, that's because in any layout kind of file view, there's going to be on the top right corner 3 options: design tab, code tab, and the one I would normally use, but I can't because it'll make things too small, the split tab, which will basically show um, kind of what the view looks like, a preview of it, as well as the code. And actually, what I usually do is I'll be using this tab to kind of monitor the changes I'm making, but I'll be making most of the changes actually using the text, and I won't be making many of the changes through this. The one thing I do like is adding constraints with the view tab because it is much nicer to just drag and drop rather than typing this whole line in. But I guess one word of caution, one super advanced Android thing, is that actually when you do drag and drop this in, so when you do drag a constraint in, what's actually going to happen is there's going to be an error in the code that gets generated for you. So like I said before, the line of code is layout constraint from the start of this view to the start of this view. But you might notice that the ID used for this view, there's a plus here. And that plus should not be there, actually. I'm not sure why they haven't fixed it yet. But anyways, not relevant, but just a fun little tidbit. Actually, this is not folder. Get out of here. Oh, that's right. Okay. All right, I think we're ready to get started then. I might have gotten over actually a little bit, but anyways, I'll be showing you guys how to create the layout. So if you're using the kind of template, this finished solution is going to be layout finished. But yeah, basically I'll be showing you guys how to create it real quick. So, and actually one tip I do, well, what happens in the plus is nothing really happens from like a functionality standpoint, but I think it technically makes it less efficient where it's declaring the ID twice. I feel like Google probably fixed it by now, but who knows? And anyways, so okay. One thing I do when I work with the views, especially small ones like the one you see here, is even if the final view is small, I will still keep the overall layouts big for the whole time until the very end. And that's going to make adding constraints and working with the various views much easier. One other thing I do is that when I'm creating a view, a constraint layout kind of thing, I'll be describing what's going on verbally as I'm doing it as well. And actually, let me take this opportunity. Keep it open. I'll be describing what's going on verbally as well to kind of determine how I add my constraints. So the first thing I notice is that the switch is a bit after the start of the screen. So that's what I'm going to do. I'm going to add a constraint from the start of the switch to the start of the screen with a small margin. The switch appears to be centered within the list, so let's do that as well. So just by adding those two constraints, it's now centered. This first text view appears to be slightly after the switch, so let's add a text view in and make it slightly after the switch with a small margin. And this text view appears to be slightly indented in comparison to the first text view. Notice how I described the relationship between the second text view to the first text view and not to the switch. That's why I'll be adding this constraint from this text view to the other text view and adding another small margin. And these two text views appear to be spaced equidistantly along the y-axis. So let's select both of these views and add a chain, a vertical chain in. And that looks just about ready. So let's make the height of this wrap content so that it's just as big as it needs to be. And it looks like these also need a bit of a margin as well. So let's add a margin there and a margin there and a small margin between the two. I only need to add it to one of the views, not those. So that looks just about ready. Hopefully everyone has this file ready now. So a file called something along the lines of list item with this view in it. This is going to be very important because we're about to start the Recyclerview section. So some of you might be interested in having lists in your application. And lists might seem simple, but there's a secret evil to them that I'm going to explain at the end. And actually, even if you're not using lists, this is going to be a good introduction on how to work with a lot of the more advanced Android kind of view components. So let's get started. Let's talk about the three basic components of a Recyclerview in Android. And the first one and the last one are pretty easy to understand. So, to show a list, you obviously need data to back up the list. So in this example, the data will be like what flights there are, what are the prices, where are they starting and departing, what time they are, how long the flight's going to be. So we need all that data to actually like display something, pretty intuitive. We also need the actual view itself, so we need to have like an actual thing, like a container to display all this information in. The middle piece is the key to this puzzle then, the adapter. And what the adapter does is it will take the data and it has access to the views. What it's going to do is it's going to kind of be the bridge between the two. It's going to use the data it receives to correctly populate the views and make it look how you want it to look. So let's get started right away with the coding. I think one thing I forgot to do in this template file is in the module build. In the module build.gradle, I forgot to add in the Kotlin Android extension. Not a big deal if you don't want to use it. It just means you'll have to use find view by ID, which I don't like doing because I'm lazy. So I'm going to add that in. But anyways, not a big deal. Okay, so let's talk about the first piece of the puzzle, which is going to be the view itself. So inside inside the activity main layout file, I'm going to add in the Recyclerview item. Well, actually, let's get this text view out of here. I'm going to add in the Recyclerview item. And I'm going to, well, it's already matched parent for both, so I'm just going to add in 4 pretty simple constraints. Every view needs a constraint no matter what. But yeah, this is pretty simple. The list is just going to be the entire screen, so nothing complicated here. Obviously, if we want to have the Recyclerview, we need to have the actual Recyclerview somewhere in our actual screen. So that should be pretty simple to understand. We're not quite done with the view yet, though, because inside main activity, we're going to need to add some code to it. So the first thing we need to do is get the. Oh, I didn't give it an ID, did I? I did not. So let's give it an ID, Recyclerview. Looks good. So now that has an ID, let's get the actual view. And let's give it a layout manager. And what a layout manager does is it's responsible for kind of positioning the views inside the actual list. And this might be confusing, but it's actually really, really simple. So simple that you might overcomplicate it, but there's nothing in Android saying that items in a recycler view has to be one by one by one like this. We actually have to say that specifically by using a linear layout manager. And for a linear layout manager, we need to give it the context. So which activity is it going to go into? But we need to do this just so that the recycler view will display items in a line like you see here. So one item at a time, one after the other. Yeah, super simple. If you're making a list, you're probably also going to be using a linear layout managers. There are other managers, but they're pretty specific. What do you prefer, Java or Kotlin? I already did the Kotlin section, but if you want to ask that again at the end, I'll be happy to answer that. So, okay, the other thing a recycler view needs is the adapter. Adapter equals, but we're not quite ready yet to make the adapter, because before we can make the adapter, we need some data. And this is where data classes is going to come in. I'm going to define a data class, and let's call it list item. Actually, all capital case. List item. And let's make it something simple. Let's just make it 2 strings. So val entry 1. So let's make it a value of entry 1. That's a string. And a value of entry 2. That's also a string. Okay. What a data class is it's a really handy tool that Kotlin gives us that lets us make classes meant to hold data super easily. So just by doing this, our list item class has getters and setters for entry 1 and 2 already done for us. It has instantiation functions all done for us as well. It has like equality functions all done for us. It has 2 string functions all done for us. It has a bunch of basic functions that's all done for us. So now that that's ready, let's make some mock data just to work with. So let's make a value that's dummy data. And let's make it a list of our list items. And let's make it something simple like entry 1. At this point, you can make it whatever you want as long as they're 2 strings. Nothing complicated. And, for now, I'm just going to have 3 of them. But anyways, all right. Now that we have our data ready, let's get on to the adapter. And I confess, I actually never create an adapter from scratch. Let's make a file for the adapter. So inside where the main activity is in the same folder, let's make a new Kotlin file called my adapter. And I actually always copy the adapter from the documentation. So this is a guide by Android for creating recycler views. At the bottom, there's a little sample for what an adapter looks like. I always just copy it from here. So I'm going to copy that and paste it. If you want, you can go ahead and find the same file. You just got to Google Android recycler views, and it should be the first link. So I'll give everyone a quick bit to work with that. But in the meantime, let's do some things. So the class name has to match the file name. So let's just rename this to my adapter. Actually, let's right click on it and rename it to my adapter. Let's import in a bunch of stuff. For me, it's Alt Enter to import. If you're on Mac, it's going to be Option Enter, I believe. But anyways, let's import everything that this file uses. Okay. That should just about do it. Okay, let me explain every step the adapter does, and hopefully that will make a lot of sense on how the adapter works. So the first function I want to talk about, oh wait, shoot, my bad. The first thing we need to do actually is our dummy data is a list of list items. So we actually need to tell it here that the data set it should be expecting is a list of list item. From main activity, this looks correct. So okay, so now that our adapter has the right data type to expect, let's move on to the functions here and what they mean. The simplest one is get item count, which all this does is tell the adapter how many items to expect in the list. And this is super simple because most of the time you just be taking the data set and like calling some sort of like .length or .size function on it. And that's exactly what we do here. You just take the data set and call its .size function. Nothing complicated. Okay. The next step I want to talk about is Oncreateviewholder. What this function is for is the adapter is going to call this function when it's ready to create an item, when it's ready to create the view for an item. So we can see here it gets the layout inflator. The layout inflator is basically like a view maker, and it's going to make a layout for us. And in this case, let's use our own custom list item layout that we made from before. So this one. And what it's going to do is it's going to make the view and put it inside a view holder. A view holder is our own specific class. You can make this view holder as complicated or as simple as you want. It's really for our use to make working with a view a lot more simple. But anyways, for now, you just need to understand that this function, the adapter is going to call this function to create the actual view item. So it's going to make the view and store it in a view holder. Okay, let's move on to the view holder then. What should the view holder do? I guess our view has these two text views, so we probably want to work with those. Let's do val text view equals view dot, what ID does this have? Oh, text view, perfect. Dot text view. And val text view equal, text view 2 equals view dot text view 2. Okay, so now our view holder holds these two text views for us. Pretty handy. All right, the final piece to this puzzle then is onBind view holder. And what this function will do is it's gonna, when the adapter is ready, it's gonna give a view holder and tell us what position in the data set it should be. So we have our view, we have our data, we have our data and what position it is. All that's left to do is write the code that's going to make the view look like what we want it to look like. And this is likely where the bulk of your code is going to be. So let's see what we need to do. So viewholder.textView.text. Let's make that data sets position.entry1. So we're going to get the item for this current position from the data, and we're going to make the text view display entry 1 and text view 2 display entry 2. All right. And just like that, I'm pretty sure our adapter is ready. It gets how many numbers there are. It has a way of creating the views, and it has a way of populating the views. So let's go back here and do my adapter. And we need to pass in the data that it should use. Okay, let's run it and see the fruits of our labor. Unless I forgot something, which I hope I didn't. But anyways. But you know what? Even before this function finishes, let me move on right away and ask you all, did you catch the error I made? And you might look like everything works and it's fine, but I have purposely made a very, very subtle error. That's, to be honest, very hard to catch unless you're very familiar with Android. And I actually made this entire Recyclerview section for this one slide. It's kind of like a bad joke in that sense because everything else so far has been leading up to this punchline. To be honest, everything else you learned with adapters and lists, you could have learned in a guide. You could have learned in this guide actually, but the thing I want you guys to understand, and let's get started on that. The first thing I'm gonna do is I'm gonna add in a whole bunch of new entries. Let's a whole lot of them. Yeah, that should be enough. And if I run it now, there should be a new area that's going to show up, and it's going to have to do with these switches. So entry one, let's put the switch on, and let's go down now. And you might notice this switch should not be on, but it in fact is. Why is that? And actually, if I switch it off and scroll back up, the switch we turn on for entry one is no longer flipped anymore. This is the point I really want you to understand on why this issue is happening. It is because the recycler view is recycling. To solve this issue, it's really important to understand how Recyclerview works. What a Recyclerview actually does is, even though it has access to the entire list and all the data, it will only instantiate the views that are currently visible. So these are the views that's currently visible. That's all the Recyclerview is going to get ready. It's probably going to get ready a few more just for scrolling purposes, but that's it. And what's going to happen as you scroll is you're going to notice that entry one is now off screen. You can no longer see it. What the recycler view is actually going to do is it's going to take entry one's view and recycle it. It's going to reuse that entire view for this new entry. So as you're scrolling, it's reusing the views that are now off screen. And that's why when I flip entry one on, it also flips this one on. It's because they're the same views. Changing one will change the other. So that's kind of my massive point here. You can't assume that items in recycling will start in the default state, and you can't assume items in recycler views will remember what state they're in because they're being recycled. We need to keep track of that. And in order to do that, let's go into list item and add in a variable checked that's going to keep track of that if that list item is checked or not. And let's make it a Boolean. And I don't want to make a new instantiator, so let's just make it a default of false. So we add a new value, it's a Boolean, and by default, it's false. Now, what we have to do here is, I guess, first of all, in our view holder, let's also store the switch. It's view.switch. So now we're holding a reference to the switch, and when we're binding it, what we need to do is do view holder. We need to get the switch, and we need to set the checked. So I guess yeah, is checked to use our data instead. We can't assume it's going to remember or be in the correct position. We have to keep track of that instead of ourselves. And we also need to keep track of when the data changes as well. So from experience, I know the function we need is, oh, not that one, switch dot on check, set on check change listener. So what we need to do is whenever the switch is checked or not, it's going to notify this listener and run this block of code. And it's the variable we really want. So we're going to take our data set, the current position, and we're going to make the checked value to be updated to the most recent, so the new value. All right, everything looks good to go. Let's run it again. And I wonder if my workshop helpers caught on, because I also purposely made another mistake here. So now you can see the switches are no longer flipped on, but if you scroll back, switch one is now unflipped. And this is my final warning to all of you. You really do be careful of what's being recycled and what's being remembered, because on-check listeners are just like any other variable in a view. If I don't specifically set on-check listener to null, this on-check listener is going to carry on after it's been recycled. And in this case, to solve it, we have to change the order of operations. But like I said, my warning to you all is just to, if you're working with recycler reviews, be very, very careful of what you're actually recycling and what you're not recycling. Yeah, anyways, everything works now, so that's all good. But the reward really is worth it. Anyways, I think that's the end of this workshop then. All right. Thank you all for being here. I know most of you came from my intro one, so lots of dedicated people to Android. But anyways, hope you guys all learned a bit of interesting Android knowledge for today. I really do think if you want to succeed as an Android developer, you need to understand how recycler views work. You need to understand how adapters work. You need to understand how constraint layouts work. Before you go, I left a new poll in the workshop. If you want to answer how difficult or how appropriate the difficulty was for the workshop, I would appreciate it a lot. But if not, then you can feel free to ask me or any of my workshop helpers, which are probably going to hop on the call now, any questions you want. Yeah, it doesn't have to be super serious questions. Like it's honestly all chill. Just ask whatever you want. Yeah, thank you for being here. Honestly, like Android is a tough place to be since like most of this is super specific to Android. Like it's not like learning this is gonna benefit you that much outside of Android, I guess. So yeah, if you guys do an Android hack, I really hope you guys make something super great out of it. Oh, I guess while you're still here, let me shout out my advanced workshop. The last one's super short, only 30 minutes. So if you want to attend, the main thing I'll be talking about there is going to be multi-threading and how to make use out of all the cores of a Android phone. So how to properly do its asynchronous programming and concurrency in Android. It sounds super scary, but honestly, with Kotlin, it's not that scary at all. Super approachable. Hmm. Let's see if I've got anything for today's workshop. I don't think so. But yeah, looks like that's going to be probably it for this workshop. Not too many questions coming in, but it's okay. I'll be on the Discord after this as well. So, if you're not comfortable asking questions in a big call, or you just want to message me like privately, that's also okay as well. And I think I'll be present for the actual hack weekend as well. So if you're making an Android hack, then feel free to just reach out to me and I'll hopefully answer your questions.